everyone, this is Komal from EC first year section B. My presentation is about designing a vending machine using sequential circuits. The problem statement that I have is to design a vending machine using sequential circuit. It should be a Moore machine that accepts nickels worth 5 cents and dimes worth 10 cents to dispense a product worth 15 cents, and it should also handle overpaying, and after dispensing the product it should reset to its initial state. The definition of a Moore machine is the output only depends on the current states and not on the current inputs, but in a Mealy machine the output depends both on the current states and current inputs. That is the main difference between Moore and Mealy machines. The design steps are: first, to draw a state diagram to understand the working of the vending machine. In the second step, we are going to choose what type of flip-flop we are going to use and make a translation table for it. In the third step, we are going to make next state table to derive Boolean equations in the fourth step, and using the derived Boolean equations we are going to draw circuit diagram. Coming to the first step, we have 4 states A, B and C, D. The first state represents 0 cents, and the second state B represents 5 cents, and the third state C represents 10 cents, and fourth state D represents 15 or greater. For no money deposited, the input is 00. For a nickel deposited, the input is 01. For a dime deposited, the input is 10. In the first state, after a clock cycle, if no money is deposited, it stays in state A. If a nickel is deposited, it goes to state B. If a dime is deposited, it goes to state C. Similarly, if no money is deposited, it stays in B in case of state B. If a nickel is deposited, if it goes to state C, and if a dime is deposited, it goes to state D. When we comes to state C, if it is going to go to state D if we deposit either a nickel or a dime, and if it doesn't deposit any money, it's gonna stay on the same state. And when we come to state D, the soda is going to get dispensed during the next clock cycle, irrespective of the input that we give, but the final state is going to matter on the input that we give. If it doesn't deposit any money, it's gonna go to state A, and if we give nickel, it's gonna go to state B, and if we deposit a dime, it's going to go to state C. The flip-flop type that we are going to use for this design is a D flip-flop, as it is easier to create a next state table. In step 3, while creating a next state table, we are assigning 00 to state A, and 01 to state B, and 10 to state C, and 11 to state D. We are using 2 bits as there are only 4 states. These next state names are derived from the state diagram, and these codes corresponds to the A for A 00, B for 01, C 10, and for D 11. The output is low for all the other state except D, as we are going to get soda in the final state D. Here the flip-flop inputs are derived from these, the next state codes, as it is a D flip-flop. These two corresponds Q1 plus and D1, and these two also corresponds. From the next state table, we are going to derive Boolean equations from D1, D0 and Z using a K-map. If we observe here, the Z does not depend on any type of input, it only depends on the current states. This is the definition of a Moore machine, and this is the final circuit diagrams of it. The thing that we need to observe here in these diagrams is this NOT gate, and this is going to ensure that we are going to get the output after reaching the state D, not while reaching the state D. And this is the important point in these circuits, and that's all. These are derived from those Boolean equations, and this is the end of my presentation. Thank you.